Several times already in the course, I have mentioned this idea of testing your program. And I think this is a very, very important concept. It's always amazed me that a student could turn in a program and not really test it at all. And of course, if you get a job either being a programmer or a job that involves programming, you better do some pretty thorough testing of any code that you generate. And it might be your job to actually test the code somebody else made or created. So let's look a little further into this concept. So what I have here in Wing is some code here, and I just made this up for an example. So let's look at what this test program does, and to make this section here more readable, I just copied it out and put it in Notepad and increased the font size. This is what you see here. So this program prompts the user for a float value. And of course we need to check that, make sure it's a float value or something that can be treated as a float. Then the program is going to validate the input to ensure it falls within a certain range. And I just picked 0.1 to 10.0 inclusive. Now next, if the input is invalid, either non-numeric or out of bounds, I want it to loop and prompt the, well, it's first going to prompt the user to re-enter, and then it's going to loop back to the validation code and validation and range checking code. Now, once these conditions are met, the program simply takes the input float value and classifies it into three categories. The number is either 0.1 to 1.0, and we're going to call that float in, the float value is in the range 0.1 to 1.0. The next category is greater than 1 but less than 5, and this is what we're going to call that, and then 5 and above. So it's really doing nothing in particular. I just picked out some ranges to show you how you need to test something. And then we do a simple calculation here. Now, one of the things I noticed when I was playing around with this is I left this like you see it, hoping that you could look at this and say, well, there's a problem here. And the problem is, notice these greater than and less than signs. The actual value 5 is not put into any category. So that's the kind of thing you need to be looking at when you're testing your programs or testing someone else's code. And we call this an edge case. It's right on the either exactly on a boundary or very close to a particular boundary, in this case, for lack of a better term. So we'll investigate how this works out later on in the video. So that is this part. Now let's go through the program and see how it works. So if you go all the way down here, and this code here just simply makes sure that the proper script named this is ran, and it calls main. And these are three functions, one of which is the main function. So main is going to display a prompt. So here I've assigned to a named constant called minFloat the value 0.1, and to a named constant called max float 10.0. So it's always a good idea to use named constants where appropriate. Then we move on down here and we call this function float val, which is then we come here and we're going to assign to this variable the value returned by this function, which is right here, and we're going to pass, notice, three things to our function: a prompt, a min value, and a max value. Now, these are generic, which means you could copy this, put it in your bag of tricks, save it somewhere, and then use it anytime you needed to input a float value and test for limits. So let's see what we pass to this function. We pass the prompt, and notice these values are filled in using the values in our named constants. And then we're going to actually pass these as parameters. So right here, this is the prompt. Okay, and these are going to get filled in with these values. And then further, we're going to pass these as min val and max val. So these values that we've stored in these named constants gets passed as well. So that's what is passed to this function. So let's look at what happens inside the function. There's a while loop, while true, and what's going to happen here is this is going to run forever until the conditions outlined here inside the loop are satisfied to the point where the function returns a value. Okay, so here's what's going to happen. The variable value is going to issue the prompt or display the prompt. It's going to take the prompt, whatever's input by the user, which is of course a string. It's going to turn it into a float. It's going to try to turn it into a float. If it's successful in turning it into a float, this loop further checks to see if the value is between the min val and the max val. If it is, that value gets returned. If this condition is not met, the else part of the if then else is executed, and this is going to print out a message saying, your input must be between min val and max val, and please try again. Now, if your input can't be converted into a float, you're going to get the accept code here, and you're going to trigger or you're going to throw a value error, and you get this printed out. And if you get to here, you're going to go back and loop again and go through this whole process. Only if this is satisfied, user inputs, well, you have a float between the min and the max value, and then if these conditions are met, it's going to return the value to the calling line in the program. Now, if you're sitting there thinking, well, wonder why we didn't use these magical, meaningful variable names inside this function. Well, in this case, we want to design this so that we can use it again. And so we want this function to be pretty well applicable to a number of cases. So that's why these variable names are not terribly specific. So at this point let's assume we've entered an integer or a float, either one of which can be converted into a float. And remember, they were initially strings. So if we get a float value here within the limits, this is returned values returned, and it's stored in this variable, float value. Now we come on down here and we want to put this value in categories. And again, I just made this up. So here we've got our minimum value. If the float value is greater than or equal to that, or if it's less than or equal to 1, we just get this printed out. If it's not in this range, we go to the else if. If the float value is greater than 1 and less than 5, this gets printed out. And finally, the final else here, if the float value is greater than or equal to 5, we're going to print this out. Now notice that we didn't specifically have a conditional like this here, and the assumption is if this condition is not met, and then this condition is not met, the only thing that's left is it must be greater than or actually equal to 5. So I would actually change this right here and put in an equal sign. Now that I think about it. And then finally, we're going to store this in result just for printing purposes. And we print out these two messages. So let's run this. And one of the first things I always do is on a program, figure out what has to happen. What's the main function of the program? Let's get that working first. And in this case, this is the thing that we really need to work. So I'm going to test this out first. So here's my prompt, and I'm going to enter a 3.4. It's that can be turned into a float value. So the categorization of this is greater than 1 but less than 5, and that's certainly true. And I just included a simple calculation here. Just multiplies it by 2. And I put that in just to make sure that, and that's this function up here. It just multiplies it by 2. Just as an example of, once you get your numbers, once you go through this if then else structure, do something with the number, perform some calculation. So that worked, and that's good. Let's run it again. So let's see, that was the mid category. So now let's do a 0.4. How about 0.45? Okay. So that was an acceptable input, and it put it in the right category and did the calculation, so I feel good about that. Run it again, and this time I'm going to do 6.77, say. And this is greater than or equal to 5, so, and the calculation is correct. So I tried all 3 of the possibilities. Now, when I'm developing the program, I would do this part first. Okay, this part here. And once I was happy with this part, then I would worry about this part here, actually checking the validity of the input. Now, we've tested the basic functionality here, but we really need to check what are called edge cases. What happens if we put in 0.1? Okay, does the program handle that properly? Let's find out. So 0.1. Okay, it handled that properly. So let's try 0.10001. Okay, now there's a round off error here. Hopefully you've covered that in your 120 class. but it handled that. So I picked the exact value of of these boundaries here, and then I tried something close to that. And of course, if you did try, and you will do this later when you actually add the input uh, validation and limit testing, you're going to try 0.09. So then we get our message that we need to try again because this value is below the minimum value accepted by our code. But again, edge case. And you could actually go on out several decimal places. Now, at a certain point here, you're going to get into a round off. So that would be interesting to check out. In this case, we haven't entered enough nines yet. But anyway, you get the idea, I hope. So you need to check the edge cases. And then finally, I would get to the point where I would go back and check the code in the function that's checking for proper input type, something that can be converted to a float in this case, and also range, and all that seems to be working. So let me summarize all this, and then we'll talk about that. So I've got a spreadsheet here where I've come up with various test cases here, and I made some notes here. So tests 1 through 9, if you look at this, these are 0.1, 0.5, 1, 0.101, etc. Now these here are kind of values that should be between, safely in the middle of a particular category. In some cases, this is actually a lower bound, and this is an upper bound of first category. And this is a common, something in the middle of that particular range. So these are actually edge cases. And I need to change my note over here. So let's see. 1, 3, 4, 6, 7, and 9 are edge cases. So I'll change that right now. So let's see, I said test 2. Now let's see, test 1, 3, 4, 6, 7, and 9. Yeah, I like that better. I got in a hurry a while ago when I was labeling all this. So these are all edge cases, and these values are on the edges of these values that we're using to sort, if you will, the inputs into these various categories. So you have to test those. These are like 2, 4, 2 and 5 and 8. Let's put that down. 2, 5, and 8. Test 2, 5, 8. Oops. Are, I'd call these typical inputs. They're somewhere in the middle. Now, this comment here is still valid. I would develop my code and verify that these worked first. Okay? And when I'm happy with this, then I would move on to these. So test, let's see, do I have 10 anywhere? Somehow I missed that. Okay. Here you go, 10 through 15. These are the tests that you're going to add after you're happy with the core functionality of your program. And this is your input validation and range checking code. Let's see here, what was my note on 15? So this is that special case that I was noting a while ago. In our case, it wasn't really clear, at least to me, which of these categories the number 5 needs to go into. So you need to be particularly mindful of these types of situations. And it is also an edge case. Notice up here, we also have the same thing up here. And of course, these things are going to vary depending on your code and what it's trying to do. Finally, 16 here is just you take a valid input, do the calculation, test that, and make sure that it really does what you want it to do. So, in case you're interested in how I got this, here's your basic rules. You look at your code, and to do thorough testing, you have to make sure that the values you test go everywhere possible in your code. So, for example, here, if you just entered a value like 0.5 and say, hey, it works, well, you don't know, because you didn't test anything greater than 1 or less than 5, etc. So, for this particular program, you have to go into this function here and make sure that all possible inputs are tried. And I think we've actually missed some in our testing here. We didn't enter any Boolean values, but those will be interpreted as strings anyway, so we're good. So the point is, you have to make sure that you try a string and what happens, find out what happens. You have to try something less than the minimum value, see what happens. You have to try something greater than the maximum value and verify that it works. So that's testing. You have to make sure that every possible path through your program is tested. And this is really important because, well, that's the only way you're going to know if it works or not. Now, in another video, we'll talk some more about where all these values came from. But that's the concept. You have to make sure that every possible path through your program is taken and tested. And it does what you wanted it to do. So, there'll be more on testing.